Hello everyone, welcome to the Code, and it is the seventh part of our system design interview questions. And in this part, I'm going to talk about this HTTP 1.1 versus HTTP 2 versus HTTP 3. So it might be possible that you think that these are not the important questions, but still you don't know what an interviewer can ask. So from that point of view, this HTTP 1.1 versus HTTP 2 versus HTTP 3 is important. So before starting this video, I'm going to pop some questions in front of you. I want you to pause the screen and read them. Once after reading them all, if you think that you can answer them, then this video is not for you. But still, if there is any doubt and if you want to learn, then I want you to stay and learn with me. Okay, so here are the questions. So pause the screen and try to answer these questions. Okay. I guess you have gone through all the questions, and if you are not able to answer them, then it's all right. It's not an easy task, so we can continue with the further learning. Okay, so what I'm going to do, I'm going to teach you all the things in the animated way. So let's start with the HTTP 1.1. So this HTTP 1.1 was used at the earliest, not earliest, like it was the first thing which we used over the internet when the server is going to connect with the client or the client is going to connect with the web application or server. So what this HTTP 1.1 did, actually, when we talk about this HTTP 1.1, as you can see here, we have this TCP connection 1, TCP connection 2, TCP connection 3. So if you are going to open a site, let's say www.google.com. So this google.com have its own CSS, it have its own JS files, and also it have its own HTML. So there are three files. So to load these three files, what this HTTP 1.1 did, for the same loading that particular web application, it opened three separate channel on the internet. That is TCP connection 1, TCP connection 2, and TCP connection 3. And from that TCP connection 1, 2, and 3, it will ask from the server, okay, I have this TCP connection 1. You can send the HTML file from this channel. I have this TCP connection 2. You can send the CSS file from this channel. And I have this TCP connection 3. You can send the JS file from this connection. But there was one more thing which we need to understand. Once when these channels are opened, let's say there are multiple HTML or multiple CSS files which this application needs to load. So what it do, first it will ask for, first it will send the one HTML file, then the client will say okay, and the client will send the acknowledgement to the server. Once the acknowledgement is received, then server will send the second HTML file, and same goes with the CSS file, and same goes with the JS file. It means if I have three channels and if there are multiple files, let's say TCP connection ones need to transfer four files, TCP connection two need to transfer two files, TCP connection three need to transfer five files, because there are multiple JS files which we create for our HTML application. So in that case, let's say this TCP connection 2 is completed. In that case, this TCP connection 2 will be still alive, because it might be possible that it can be used for the other data transmission. And the other thing is, the complete transaction which happened between the client and the server is completely text based. It is a readable text which we used in the HTTP 1.1. So what will happen, let's say if there's any one heavy file. So we have this file 1 image, file 2 CSS, and file 3 JS. And file 1 is the image, because images can be large. So let's say I have this one very heavy file. Because of this heavy file and this complete file need to be transferred at once. So what it will do, it will create a massive load for this TCP connection 1, and then it will transfer it from the internet to the browser server, sorry, web application server, or from web application server to client. In this way, let's say if there are multiple images which need to be transferred from web application to your browser, in that case, it will take too much time, because there is one channel and that one channel is doing all the heavy loading, all the other channels are transferring the different kind of files. So This HTTP 1.1 was very slow. And also, not only so slow, it will take massive resource over the internet. Earlier, there were less devices. That's why this HTTP 1.1 worked. But as soon as people started using internet, it become a bottleneck for all the users who want to access a web application, because every time when you create so many resources over the internet, it will take some bandwidth and it will not fulfill the need of all the consumers. So this is all for the HTTP 1.1, and I guess I was able to teach you what is this. Okay, now let's go for the HTTP 2. This HTTP 2 uses the TLS 1.2. And same, we have the scenario of file 1, file 2, file 3, where file 1 is the image, file 2 is the CSS, and file 3 is the JS. But in HTTP 2, what happened is earlier we were creating multiple TCP connection for one application to get loaded. But in HTTP 2, what we did, we create only a single channel and we divided that channel for multiple data transaction. So if you can see, this is a single TCP connection. It is multiplexed. What I mean by multiplex, let's say for the HTTP 1.1, it was a single lane highway. Okay. And for the HTTP 2, you have a one highway with multiple lane. It means a single highway can use by multiple vehicle at the same time. And also it do few more things. What are those? It didn't use the text to transfer the data from your web application to your browser or from browser to web application. It converted the data into binary. So earlier, everything was going from the text. So all that file need to, so the file need to be transferred completely at a one go. But when you converted that data into binary, you can chop that data into multiple segments and you can transfer those segments sequentially to the destination. So this is the work this HTTP2 did. First of all, it created a multi-lane highway for the data packets. These data packets contains the binary data, and this binary data can go sequentially without waiting for the acknowledgement. But still, there is a one catch. And what is that catch? So let's say there is one lane in that particular highway, and in that lane there are 10 cars which need to go from server to destination. It means from web application to your browser. So those all 10 packets of data is going sequentially one by one to the browser, and for the same, the acknowledgement is asynchronously getting transferred to the web application that, hey, these packets are received. So let's say in those 10 packets, if any one packet get lost or didn't reach to the destination, in that case, the complete traffic will be stopped. Not only for lane 1, lane 2, lane 3 also get stopped, because in TCP, so because in TLS it is required, in TCP it is required that the complete data need to be transferred to the destination. So till that particular data didn't reach to that destination, all the packets will be stopped wherever they are. They will not reach to the destination or they will not get processed at the destination. So with the HTTP2, we can send multiple files data simultaneously using different lane of a single TCP connection. But still, that all the sequential data needs to be reached there without any missing packet. So let's say if there is any server crash, in that server crash, everything will be stopped and the complete data need to be retransferred, because everything is sequentially, and let's say that connection got broken or something mis happening event was there, and because of that the transaction was not completed. So in that case, if you try to do the same process or try to download the file again, it will download the file from the start, or it will load the data from the start, from the scratch. It will not take the existing packet, it will delete them. Okay, so let's move to the next slide, which is for the HTTP3. HTTP3 is the latest version which we all are using on our day-to-day basis. What this HTTP3 is? This HTTP3 is using QUIC. This QUIC is created by the Google, and you know how much this Google is fast. So what it did something mixture of HTTP 1.1 and HTTP 2. And what it did, when you try to connect your browser to your web application or your web application to the browser, it create independent streams. So you can see here this QUIC stream 1, QUIC stream 2, and QUIC stream 3. So let's say if you are going to open some website, and again that website is using the image, CSS, and JSS. So what it will do, it will create multiple route, multiple routes, not routes, multiple channel, but each channel is independent. What I mean by independent, let's say if something got failed at QUIC stream 1, QUIC stream 2 and QUIC stream 3 will be continue. And it means if file 1, file 2, file 3, these three files are downloading and something got missed at file 1, then file 2, file 3 will be still downloaded. And what will happen in the file 1? While the one packet is lost, it will not stop sending the data which it have at the source. It will still continue send those binary stream of data to the destination, even the single packet is missed. But what it do, it track that particular data, and after tracking that particular data, as we discussed earlier in the previous videos, that it used some offset, and in that offset it put all the binary data sequentially with the labeled, and if any particular label data is missing, it will ask something for that to the source, and the source will send it to the destination. In this way, that particular packet is completed with the data, and you can stream or you can download that file without any delay. The second thing is, if let's say if something happened and your data got disconnected, this QUIC is so smart. It can track all the things which you have. And let's say if your data got disconnected and if it connected again, then it will download the only remaining part. So it means it is fast, it is reliable. It is also tracking that what are the things which are missing and what are the things we have already worked on. So in this way, let's say if streams is server, sorry, if server stream 1 crashes, so what will happen? Stream 2 and stream 3 will work. And let's say if it gets again reinitiated, it will start sending the data from the same step. Okay, so these are the key differences between the HTTP 1.1, HTTP 2, and HTTP 3. So I guess we have completed all of the key concepts in it. Just see, there are some only few more definitions which we need to understand. That is this TCP, this transmission control protocol. So we have talked a lot about this TCP, so there is no need to discuss what this TCP is. Multiplexing, this multiplexing is started from HTTP 1.2 as it is using a multi-lane highway. It means using a single channel to create or uh, to provide multiple stream in a single channel. That is called the multiplexing in a simple words. This acknowledgement, every data packets which is getting transferred to the source, it is getting acknowledged, and it is when it is getting acknowledged, it means the source will get the information that destination received that packet and I can transfer the another packet. For the HTTP 1.1, it will wait for the acknowledgement, then it will send the second file. For the HTTP 1.2 or HTTP 3, it will not wait for the acknowledgement. That acknowledgement cycle will run asynchronously. So all the packets will go sequentially, one by one, one by one, one by one, and its acknowledgement and its acknowledgement will be received asynchronously to the source. Okay. So what is this HOL blocking? When a line of data is held up by the first packet in HTTP 1.1, it happens because a large file. In HTTP 2, it happens because a drop packet. So as I said, in HOL blocking means, as in HTTP 1.1, we have the three different three different pipes or three different connections. So in connection one, if anything got stuck or got missed, it will stop the complete transaction in that pipe. But in HTTP 1.1, the second pipe and third pipe will still continue to serve the data. In HTTP 2, as we have the single pipe, and that single pipe is working as a multi-lane highway. So if any packet got missed, it will stop the lane 2 and lane 3 too. QUIC UDP, as fast connectionless protocol. QUIC built on UTP to allow independent streams, meaning a lost packet in one file stream does not block the other. So it means in HTTP3, this HOL blocking was removed completely. So we have covered all the theoretical part. Now let's go for the questions again. And this, so why does HTTP 1.1 require multiple TCP connections? To enable encryption, to bypass head of line blocking, or to compress headers. So for the 1.1, as I said, to bypass head of line blocking so that other data can transfer without any delay. What is multiplexing in HTTP2? So opening 10 connection at once, switching from TCP to UDP, sending multiple fragment file concurrently over one connection. So we know sending multiple fragments file concurrently over one connection. Okay, we have discussed a lot about it. Why can HTTP2 still freeze if one packet is lost? Because it uses TCP, which demand guaranteed ordered delivery. Because frames are too large, or because the limit of HTTP2 speed? No, because TCP demands the guarantee. Okay, that's why TCP is still used. HTTP3 abandons TCP. What transport protocol does it use? So this HTTP3 is using QUIC, and QUIC is built on UDP. How does HTTP3 handle your switching from Wi-Fi to 5G while loading a page? So let's say, again, I told you that it is able to still reconnect the data transmission if it get lost in between. So it uses the connection ID to seamless continue the download. If you have any issues, you can watch the previous videos, because in those videos we have discussed about it a lot. So that's it for the video. And from the next part, we are going to talk about the real system design. This is one, not what I can say the real system design means. We are going to talk about the cache server. We are going to talk about the count, that how many servers we need if we have this much of users. How many cache servers are required? How many web servers are required where we need to host our application? How many CDNs are required? So there are so many things which we need to still understand and to learn, and where to implement it. So from the next part, we are going to leveling up our learning. So stay tuned, and if you like it, then subscribe it and wait for the second part. Thank you.